Hello everyone, welcome to another video. Now let's solve this physics question on the board, and I read: state one reason each why cathode rays A are not electromagnetic waves, B why cathode rays cast sharp shadows of objects in their path, C why cathode rays can rotate a light paddle wheel inside a discharge tube. So this is one question. Now the second question, we have that an X-ray tube operates at a potential difference of 2500 volts if the power of the tube is 750 watts. Calculate the speed of the electron striking the target. So we have here that the magnitude of the electronic charge is equals to 1.6 times 10 raised to the power of minus 19 coulomb. And then the mass of electron is equals to 9.1 times 10 raised to the power of minus 31 kilogram. So for the first question, we are asked to state one reason each why cathode rays A are not electromagnetic waves. There are many reasons. Then B, why cathode rays cast sharp shadows of objects in their path. There are many reasons for that as well. Then why cathode rays, can rotate a light paddle wheel inside a discharge tube. Now, the discharge tube can be used to produce cathode rays. Okay, that's the beauty of it, because cathode rays were discovered by William Crookes and J.J. Thomson in the year 1880. They used a cylindrical hard glass tube fitted with two metallic electrodes. Let me draw it on the board. Now, we have a cylindrical hard glass tube. This is what it looks like, fitted with two metallic electrodes. So this is one electrode and this is another electrode. Now, one of the electrodes is connected to the source of electricity. That is, it is connected to the negative terminal of the source of electricity, while the other electrode is connected to the positive terminal of the source of electricity. So this is the negative electrode, and why this is the what? Positive electrode. So the negative electrode is known as the cathode, while the positive electrode is known as the anode. Now, this is what we call discharge tube. Okay, the cylindrical hard glass tube fitted with two metallic electrodes. Now, this electrode is connected to the negative terminal of the source of electricity. So this is the source of electricity. Okay, so the electrode connected to the negative terminal of the source of electricity is known as cathode, and that which is connected to the positive terminal of the source of electricity is known as the anode. So these two electrodes are fitted, they are embedded inside the what? The discharge tube, which is the cylindrical hard glass tube. Now, the glass tube has a side tube with a stopcock, and that is what we call the vacuum pump. So it will be somewhere here. This is what the vacuum pump looks like. So we have the vacuum pump. This is the vacuum pump. Vacuum pump. Okay, now J.J. Thomson and William Crookes, passed electricity through the discharge tube at a very low pressure and high potential difference of about 10,000 volts. Now, the blue rays emanating from the cathode, or the blue rays which emerge from the cathode towards the anode were termed as cathode rays. So which means the blue rays emanating from the cathode towards the anode were called the cathode rays. All right, so now The first question is for us to state one reason each why cathode rays are not electromagnetic wave. Now I'm going to state three reasons. Now, because we know that electromagnetic waves consist of coupled vibrations in both electric field and magnetic field, traveling at the speed of light across field-free space or empty space or vacuum. Okay, now they do not possess mass. Okay, but in the case of cathode rays consist of a stream of fast moving electrons, okay, or it consists of particles, and they possess mass and momentum. So number one reason why cathode rays are not electromagnetic wave, okay, Roman numeral one, we have that cathode rays consist of particles. It consists of particles, and they possess they possess mass. That's one reason. Number one. Another reason is that electromagnetic wave cannot be deflected by both electric field and magnetic field. But cathode rays can be deflected by both electric field and magnetic field. So which means that we're going to have that cathode rays. Another reason why cathode rays are not electromagnetic wave is because cathode rays can be deflected, okay, can be deflected by both electric field, electric field and magnetic field. Magnetic field. That's another reason. Okay. Now also, electromagnetic waves are produced by accelerating charges or by changing electric field and magnetic field. While in the case of cathode rays are produced from what we call field emission or thermionic emission, just like what we have in that diagram, that we have the blue rays coming out from the cathode moving towards the anode. So that means that in that case, we have what we call field emission, or we can have it as thermionic emission, which is the process of electron emission from the surface of a metal, okay, when subjected to a very high when subjected to heat at a very high temperature. All right, so which means that cathode rays, cathode rays, okay, are produced. Cathode rays are produced from field emission or thermionic emission. Thermionic emission. Okay, so that's for the first one. Now we can also say that cathode rays requires a vacuum or a low pressure gas in order to minimize collision in the discharge tube. But for electromagnetic wave, it does not require a material medium. All right, so now B. Now, one reason why cathode rays cast sharp shadows of objects in their path, because cathode rays travel in a straight line. Okay, for that reason, okay, they will cast sharp shadows of objects in their path. Apart from that, because cathode rays consist of particles, or it consists of a stream of fast moving electrons, they can be blocked by an opaque object for that reason as well. So now, Roman numeral one, okay, cathode rays. That is, cathode rays travel in a what? Straight line. Okay, now let's not forget that the fact that we know that electromagnetic wave, okay, travels at the speed of light, okay, in a straight line. Okay, it travels at the speed of light. But for cathode rays travels at a speed significantly less than the speed of light. So that's it. All right, Roman numeral two. Another reason is that Cathode rays consist of particles, and can be blocked by an opaque object. It can be blocked by an opaque object. Roman numeral 3. Roman numeral 3. Now, another reason is that now cathode ray beam, okay, possess high intensity, okay, which creates a noticeable contrast between the shadowed area and the what? Unshadowed area, like that way. That is cathode rays, cathode ray beam, okay, possess high intensity. It possess high intensity. It possess high intensity, which creates a noticeable contrast between shadowed areas and unshadowed areas. Okay, so that's Roman numeral 3. Okay, now next, let's talk about why cathode rays can rotate a light paddle wheel inside a discharge tube. Anyways, a light paddle wheel is constructed in order to reduce or minimize inertia and allow for easy rotation. That's number one reason. Okay, now number one reason, like I said, a light paddle wheel, a light paddle wheel is constructed a light paddle wheel is constructed, okay, to minimize, is constructed to minimize the effect of inertia and allow for easy rotation. That's Roman numeral 1. Roman numeral 2. Another reason is because the vacuum environment can also reduce the effect of frictional force that would impede the what? The rotation of the light paddle wheel. That is, the vacuum environment. The vacuum environment. The vacuum environment reduces the frictional force. Reduces the frictional force. Reduces the frictional force that would further impede the rotation of the paddle wheel. Nice. Let's take one more reason. Now, another reason why we have why cathode rays, okay, can rotate a light paddle wheel is because cathode rays consist of a stream of fast moving electrons which possess mass and momentum. So which means that when cathode rays strikes, okay, the paddle wheel, or when it strikes a light paddle wheel, their momentum will be transferred to the what? To the paddle wheel. Okay. Now, so which means another reason is because um, cathode rays possess mass and momentum. Okay, mass and momentum, and when they strike a light paddle wheel, when they strike a light paddle wheel, when they strike a light paddle wheel, their momentum, their momentum is transferred, is transferred to it. So we have, for the first one, cathode rays consist of particles and they possess mass, okay, or they have mass. Then we have that cathode rays can be what? Can be deflected by both electric field and magnetic field, but electromagnetic waves cannot be deflected by electric field and magnetic field. Okay, and also electromagnetic waves do not possess mass. Now, cathode rays are produced from field emission or thermionic emission. That is the emission of electrons from the surface of a material or a metal, okay, when subjected to heat, okay, at a very high temperature, or to a very high temperature. All right, so now, also, why they cast shadows, okay, of objects in their path? That is because cathode rays travel in a straight line, okay, and that is also because cathode rays consist of particles and can be blocked by an opaque object. Then also, it is also because cathode ray beam possess high intensity brightness, okay, which creates a noticeable contrast between shadowed area and unshadowed area. Now, the other one is why cathode rays can rotate a light paddle wheel. That is because, now, the first reason is because a light paddle wheel is constructed to minimize inertia and allow for easy rotation. Then two, the vacuum environment reduces the frictional force that will further impede, or that would impede, the rotation of the paddle wheel. Then also, Roman numeral 3, we have that cathode rays possess mass and momentum, and when they strike a light paddle wheel, their momentum is transferred to it. And we just answered, and these are the answers to the first question. Now, the second question, I think this is question 7 and 8. Okay, S.S.C.E question 7 and question 8. S.S.C.E 2010 section B part 1. Yes, this is part 1. All right, so question 8. An X-ray tube operates at a potential difference of 2500 volts. If the power of the tube is 750 watts, calculate the speed of the electron striking the target. Now we're given the potential difference of 2500 volts. 500 volts. Then we're also giving the electronic charge. Electronic charge is 1.6 times 10 raised to the power of minus 19 coulombs. Then also we have that the mass of electron is 9.1 times 10 raised to the power of minus 31 kilograms. Okay. Now, so what again? That's okay. Then we're also giving the power. Power is given to be 750 watts. So which means that the accelerated electron will acquire enough kinetic energy, okay, when the electron strikes the target. Yeah, when it acquires more kinetic energy. So in this case, we have that the electron volts, okay, EV equals to KE, so that EV will be equals to 1/2 of ME VE squared. Okay, because the electron is accelerated, that's why it means that it gains enough energy, to move. And then the speed of the electron striking the target is V subscript E. So if we make VE subscript E the subject of the formula, this will be equals to the square root of 2 EV over mass of the electron. So let's plug in the value. So we have that this will be V subscript E equals to 2 multiplied by 1.6 times 10 raised to the power of minus 19, then multiply by the potential difference, which is 2500, divided by the mass of the electron, which is 9 times 10 raised to the power of minus 31. Okay, 2 times 2500, that will be 5000. 5000 multiplied by 1.6. That will be 8,000. So in this case, we have V subscript E to be 8 times 10 raised to the power of 3 multiplied by 10 raised to the power of minus 19. 8,000 is 8 times 10 raised to the power of 3 divided by 9.1 multiplied by 10 raised to the power of negative 31. So velocity of electron, or the speed of the electron, will be, now let me get the value for what is 8 divided by 9, 9.1. I don't want to, 8 divided by 9, 9.1, that will be 0.879. So we have 0.879 multiplied by 3 minus 19, that will be minus 16. So I'll bring this up, this will be minus 16 plus 31. So the velocity of the electron, okay, will be, so this will be 15. So we're going to have square root of 0.879 multiplied by 10 raised to the power of 15. So which means now I can write 10 raised to the power of 15 as 10 times 10 raised to the power of 15. So 10 multiplied by 0.879, that will be 8.79. So that the velocity of the electron will be square root of 8.79 times 10 raised to the power of 14. So the square root of 10 raised to the power of 14 will be 10 raised to the power of 7. So what is now the square root? Okay, square root of 8.79, that will be 2.96. 2.96. So this will be 2.96 multiplied by 10 raised to the power of 7 meters per second. So the velocity, or the speed of the electron striking the target, is 2.96 times 10 raised to the power of 7 meters per second. Let me just write it here and box it. So we have the speed of the electron striking the target to be 2.96 multiplied by 10 raised to the power of 7 meters per second. And we've come to the end of this tutorial. The quality of your preparation will always determine the quality of your performance. So get started. Bye-bye.